Good afternoon. No water, no life. No blue, no green. World Water Day observed on 22nd March every year since 1993 focuses on the importance of fresh water. I welcome everyone for the 40th episode of Creative. As we know, life could not be possible without water. Most dried areas of the world depends entirely on groundwater. Water is not only important for drinking, sanitation, food production, and industrial process, it also critically important to the healthy functioning of ecosystem such as wetlands and rivers. We must protect them from overexploitation, abstracting more water than is recharging by rain and snow. The population that currently hunts them, it can lead depletion of this resource. Extra cost of processing it and something even preventing its use. It's our responsibility of us to take action to tackle the global water crisis. Let us join us hands to conserve water. To create the awareness, Creative arranged a talk on ocean color remote sensing application. To present this, we have high-profile eminent speaker, Dr. P.V. Nagamani. Ma'am, before we start, I like to brief about Creative. Creative is a group of curious minds and like-minded people who are eager to gain the knowledge. Meaning of Creative, to be active, we need creativity. Creativity, and to be active we need creativity things keeps us active. Knowledge square is our tagline. Sharing of knowledge will increases our knowledge. Vision of Creative to build constructive thinking on various fields and progress in various fields, and our focus on non-textual, non-academic, non-syllabus related concepts. We are very thankful to all our resource persons for engaging us with their knowledge, innovations, reviews, and more. Every Saturday, we are arranging creative talks. Weekend talks between 3 to 4. Every talk on Zoom platform, and we live streaming our program on our YouTube channel, and we have other social medias where you can follow us for more updates. And India celebrating Azadi Ka Amrita Mahotsav on the occasion of 75th Indian independence. We also labeling our talks on Azadi Ka Amrita Mahotsav label. And I welcome one and all for this session, and I call Sai Madhuri, who is creative volunteer, to introduce today's speaker. Over to Madhuri.
Yeah, thank you, ma'am. Today in this creative episode, we are having a superwoman actually. Why? Because after looking at Nagamani ma'am's profile, I really felt astonishing at ma'am's work. Here I am Sai Madhuri, going to introduce today's speaker, Dr. P.V. Nagamani ma'am, scientist, SG, head and ed at ISRO, Hyderabad. Hyperspectral ocean color remote sensing, optical oceanography, algorithm development, satellite, almighty are the ma'am's areas of interest. Let me discuss about ma'am's professional experience. Ma'am worked at National Geographical Research Institute, Hyderabad as Project Fellow and SRF from 2000 to 2003. Space Applications Center, ISRO, Gujarat as Scientist SC and SD from 2003 to 2009. National Remote Sensing Center, ISRO, Hyderabad as Scientist SD, SE, SF, SD from 2010 till now. Ma'am is a life member at Indian Society of Remote Sensing, Indian Meteorological Society, Astronautical Society of India, and Indian Geophysical Union. Ma'am completed PhD Geophysics at Osmania University in 2007. ISRO Young Scientist Award in 2010, Best Poster Award, SAFRI Symphonium Cochin. PhD Research Supervisor Recognition in Department of Physics, JNTU Hyderabad, AU College of Engineering and Technology, and AU College of Science and Technology. Academic visitor to Polymouth Marine Laboratory, UK. Nominated for International Astronomical Society Conference at Cape Town in 2011. In 2000, NGRI DST Project Fellowship. In 2003, CSIR Senior Research Fellowship are MAM Awards and Grants of Nagamani Ma'am. Academic responsibilities of MAM are: MAM guided 15 students for completing their IITP projects, 25 students for their BTech and MTech projects, 2 students from IIST ISRO for their summer projects, and 6 PhD students. MAM is reviewer at Journal of Indian Society of Remote Sensing, International Journal of Remote Sensing, Atmospheric Science Letter, and Current Science journals. Research and operational projects of Nagamani Ma'am are OceanSat 1, OceanSat 2, and OceanSat 3, NCP, MOP2, SATCORE, SARL, Vision, IPAR, TDA, GISAT, PACI, and Landsat 8. MAM is NRSC Women's Committee member, ISRO MOES Joint Activity Committee member, AVIRIS Science Team member, NRSC HRD Committee member. MAM has experience in modeling of underwater light fields using hydrolight and VASI and many more. MAM knows software and instrumentations like OS and programming languages, image processing packages. MAM attended prestigious workshops conducted by ISRO, Indo-US, and many more. MAM delivered many talks regarding ocean color remote sensing at many places. It's really a difficult thing to mention all the publications of MAM. Why? Because nearly more than 50 publications are there, ma'am. So sorry, due to time shortage, I can't mention them all. So this is about our speaker, Dr. P.V. Nagamani, ma'am. It's our pleasure to have such a great personality with us today in our creative session. On behalf of all the participants and creative team, I welcome you, Nagamani, ma'am.
Thank you, Sai Madhuri. Ma'am, over to you.
Yeah, good afternoon, everyone. I'm Nagamani, working in the field of ocean color remote sensing at National Remote Sensing Center, Hyderabad, under ISRO. Today, I'll be giving a brief introduction about what is ocean color, how the oceans are responsible for various societal benefits, and how their applications can be used for day-to-day life. And for retrieving those parameters, or by simply looking at some of the natural waters, how we will identify how the color is really used for identification of various parameters and their processes, how they are resembling, and their applications. I will be telling about some of the things. So I will now share my screen for your better visibility.
It's visible, ma'am. Ma'am, muted, ma'am. Yes.
Is it audible now?
Yes, ma'am. A little bit louder, ma'am.
Yeah.
Okay.
So Today I'll be presenting some of the basic concepts of ocean color remote sensing and its applications. So coming to the next slide. The presentation outline will be introduction to the basic concepts, which include what is remote sensing and the space observation and its unique advantage. Then what are the remote sensing applications generally we do from the space-based platforms. Apart from that, the remote sensing in terms of specifically for marine biology or ocean science or oceanography, which is dealing from the ISRO missions, and why we need to study the ocean color or oceans, why we need to study, and what are the synergistic studies that we can carry out using remote sensing as far as oceans are concerned. And then coming to the basic presentation, the title like ocean color. What is ocean color? How satellite ocean color is measured or it can be identified? And what are the ocean color remote sensing sensors and their characteristics in terms of their spatial, temporal, and spectral coverages and spectral resolutions are concerned. And the primary products that we are getting from the Indian EVO sensors like Ocm1 and 2. And the applications of ocean color remote sensing in taking, though we are having the other contemporary and the previous ocean color sensor from CGL series onwards, and the applications I will be emphasizing only for the ISRO EVO missions, and then the basic concepts of ocean optics, and then atmospheric collection, how we have to retrieve the parameters, and what is the major component that we are supposed to consider for retrieving the concepts or the concentrations, and the algorithm that are involved, and then the basic applications. So coming to remote sensing, and as everybody knows that remote sensing is a science and art of collection of information or collecting the information of any object or a space or a thing without being a physical contact with it. The sensor is located either in the air or space-based platforms or any aeronautical service or any sublateral platforms also is considered remote sensing. If we say the basic concept, we can see that the eye also is basically a remote sensor where we can see the objects without being a contact and getting the information, whether it is a textual information or structural information or tonal information. So if we take eye as a basic example for the remote sensing, the other things can be easily interpreted. So what are the space observations and their unique advantages? Generally, the remote sensing can be done using different platforms, as I said that, with basically from the land platforms and the air-based or the airborne surveys and then satellite surveys. So generally, if you are coming very closer to the Earth, at the near surface observations, the coverage will be high or the visibility will be high, but whereas the coverage will be less and it takes a lot of time. If we go to little higher platforms like airborne surveys, the visibility will be little high and the coverage will be more. The repetition can be taken care. If you go to the even much higher platforms like satellite-based remote sensing, where your platform is much higher, that means the distance from the object to the height of the platform varies from 700 kilometers to, if it is a geostationary orbit, it goes to 36,000 kilometers. So the visibility increases. Why we have to go for different types of observations and data collection as far as remote sensing is concerned is one is for the repeativity or the coverage of the same object for the various applications. One is for its resolutions for some synoptic applications. If you see why we need space observations is that so generally we used to have the sensors which are uniform and highly well calibrated observations can be taken care, and they are ideally suited for dynamical processes. In the sense that if you want to see some of the like oceans or the water bodies, if you want to sense or if you want to do the analysis, you need to have a space-based platform rather than the in-situ measurements or the other platform which are like UAVs and all. They are very temporary. If you go for the orbital based or the very systematic coverages, these dynamical process can be studied over a period of time, both in temporal and spatial scales. From that, satellite-based platforms will be very synoptic way of various processes at different spatial scales. Like if you are having a sensor, now you can see that the data which you are getting, remote sensing data is from 1 meters to 300 meters or 1 kilometers also. Depending on the application, the satellite data can be utilized. So apart from that, it is also having unique advantage like time series data can be at time to study system dynamics. Because if we want to study a dynamic process or dynamic system like oceans or any other reservoir-based studies or sediment dynamics and all, you need to have a time, how if you want to study pollutants also, you need to have a time series because today it is even the urban growth and all also you need to have time series because if it is in 2000, it is like this. After 2 years, what is the change? After 10 years, how it is getting changed? For such kind of observations, you need to have time series data. For that data will be highly useful. Apart from that, it can be spatially coverage and compatible with the ocean models. And we can fill over because land observations means we can do some of like either UAVs or airborne platforms and all. But if we want to study oceans, we are supposed to depend on satellite-based observations are the best possible way to access the oceans because it is highly inaccessible except some of the cruises or the stations where we can go for the distances, but the coverage will be less. These are all point observations. If you go for space-based observations, it will be highly accessible and you can get the entire oceans in a very high resolution and repeativity. The basic remote sensing applications cover forest management, land use management, disasters, surveying and mapping, agriculture, geology, coastal management, marine biology, and other civilian applications and environmental things, transportation. However, here, as I showed you here, we can be dealing with the marine biology, the ocean applications. So if you see this in a detailed way, the forest management, we can see this. Forest management, we can see the estimation of deforestation can be done, identify the diseased forest area, and then if we go for the land use, land cover change reductions, so we can see the changes and the urban expansions. Be taken up on the land use, land cover change reduction studies. Agriculture also we can do the vegetation mapping, types of vegetation, crop monitoring, yield estimations can also be done using remote sensing data. So in geological studies, you can say that mineral exploration can be studied and structural mapping can be studied. So in coastal management, generally what we deal with is that oil spill detection, ocean management, fish and ocean life assessment can be done using remote sensing. So as I said that why we need to study oceans, what is the need of doing ocean studies? Generally, oceans are occupying more than 77% of the entire globe, where most of the, if you can see this, carbon sequestration or the productivity is also coming from the oceans. So if you see that sea state forecasting can also be done like cyclones and the tidal effects and also can be studied from here. This also goes as one of the input for the numerical weather forecasting and weather predictions, monsoon studies, climate change studies also can be studied, also is from the oceans. So apart from that, we are also using remote sensing for the marine resource surveys, both living and non-living. Apart from that, monitoring of coastal environments can also be taken up from the satellite-based ocean color remote sensing. And apart from that, this applications which includes acoustic propagation, ship routing, and navigation. For this purpose, we will be using the ocean bathymetry, which is derived both from optical and SAR sensors. Apart from that, for this acoustic propagation and this ship routing, we need to have the water clarity parameters. So what are the synergic studies that we can carry out from the ocean parameters and processes? Generally, if we see, the ocean can be divided. The ocean is divided into three things. One is the biological processes, physical processes, and geological processes. If you see that the biological processes, which are the manifestation of the ocean biology, which is seen on the surface, is the manifestation of physical processes that are responsible for this. So in the biological oceanography, we can see this, which includes the ocean color, primary productivity, and potential fishing zones, and fluorescence-based studies for the estimation of these chlorophylls in the coastal regions. Which you are coming to the physical process where we can see this evaporation, mixed layer dynamics, eddies, and cyclogenesis also can be studied in this physical oceanography processes. In geological oceanography, we can see the coastal processes, sediment transportation, shoreline changes, etc. So taking all these three parameters of the processes, we can use these combined. See, only one parameter cannot give you a simple solution or simple interpretation. So you have to go with all these things for coming to a probable synergistic solution for ocean studies. So if we, overview of the synergistic studies I can show. So here we can see this strategic applications can be studied, where we can see the ship detections, where you can observe in this one, and ocean forecasting can be done. Then pollution studies, where if we can study the water pollution which are entering into the oceans. And then we can see the coastal ecosystems, where the coral reefs and mangroves can be studied. And the chlorophyll, which is the basic resource for the marine food web for fisheries and all, can also be studied. Ocean bathymetry. And then SST also can be derived from the satellite-based applications. Internal waves can be identified. Apart from that, the sea level rise, the sea level studies also can be studied in this, and coastal ecosystem dynamic studies. So coming to ocean color remote sensing. So generally, what is, if you can see any ocean, it is not simply blue, because the ocean color changes based on the active substances which are present in the water, which gives the color. The presence of the organisms. If you see this, some of the organisms, if you see the right side, depending on the organisms which are present in the ocean, you can see the color in green color, red color, or sometimes you can see this muddy waters also in the coastal regions which are mixed with all these things. So if you can see this, which are called phytoplankton pigments, a single cell organism which floats on the ocean surface. Apart from that, there are also inorganic particulate matter and color dissolved organic matter also present, to which plays a major role in contributing to the color of the oceans. So apart from that, absorption of light by chlorophyll pigment and scattering by suspended sediments also can be picked up from the space sensors. So the ocean color sensors we can see from CGR-CS, MOSB, which is the Indian sensor, CVIRS, and OceanSat 1 and 2. Now OceanSat 2 is in orbit, which is giving the data for ocean color applications. MODIS is another contemporary ocean color sensor for NASA. And these are the current sensors which are there in the space-based platforms for giving the ocean color. If we can see here, the sensors from CGR-CS, this is the first ocean color sensor of NASA, which is having the 6-day repeativity and 825 nanometers, 825 meters the resolution, the spatial resolution, and it doesn't have any global coverage. It is also meant for the regional waters. And MOS was the 520 meters resolution data sensor, which is having 25 different. That means the region which we are covering today will be again coming to the same place again in 24 days. So if you want to study any process or phenomena, that we have to you have to design your sensor in such a way that the sensor and the process. See, if your process is very dynamic, which changes in 1 or 2 days, then you need to have a geostationary sensor or any other platform which covers the process or which covers the area in 1 or 2 days or the minimum number of days. So if you see the other sensors also, it varies from the even in the spectral in the spatial resolutions to the repeativity of this thing, covering from the regional waters to the global coverages. If you come to Ocm1, which is 360 meter resolution, having the 2-day repeativity of 2-day repeativity, which doesn't have any global coverage. However, this is designed for covering only Indian region waters where the North Indian Ocean is covered. That is from 0 to 30 degrees latitude and around 40 to 120 degree longitude will be covered. Even Ocm2 also having the same thing. However, this Ocm2 has been modified or has been evolved to measure the global oceans in a time period of 8 days with a spatial resolution of 1 kilometer. Even now the OceanSat 3, which is coming up, but here if you can see this Ocm2 is now having 2 types of this thing. One is that Indian waters will be covered in every 2 days and the global waters will be covered in every 8 days. However, the upcoming Ocm3, which will be there maybe in this year or the coming year, where you can have the same ground resolution or the spatial resolution, and the coverage of the Indian waters is fixed these 2 days only. However, the global coverage will be 3 to 4 days. So why we need to have these kind of things is that to study different ocean processes. I'll show you this in the coming example, coming slides. If you can see this, the characteristic of the ocean color sensors, if you can see the different sensors are available from multispectral to hyperspectral. If you take the Landsat 1, 2, and 3 and other things where we are having number of bands are varying, where the ground resolution has not been changed. If you take spot HR vendor, that is having only 3 bands, whereas in OCM1 and 2 we have 8 bands. So if you see the hyperspectral sensors like OCM3, which is the 3rd generation sensor of Indian EVO mission, which is having 15 spectral bands, 12 in the VNIR, 1 in the sphere region, 1 in thermal region. And if you can see this, another ocean color sensor, another optical sensor, which is a hyperspectral sensor of ISRO is GSAT, which is having 158 bands covering from 300 to 1000 nanometers, where HISIS is another one which is having 60 bands in 450 nanometers and 256 bands in 850 to 2400 nanometers. So this is how the spectral and spatial resolutions and their coverages, where the entire EM spectrum has been covered for various applications has been designed. Each sensor is designed based on the necessity or some of the scientific observations or the questions that needs to be addressed. So if you see here the GSAT, which you can see these are the spectral resolutions and the coverages and the swath widths which are having here and various applications that are going to cover. And the GSAT mission, as far as oceans are concerned, you can see that to estimate the chlorophyll, suspended sediments, SST, sea surface temperature, and then downwelling irradiances, etc. These applications include PFZ, coastal zone management, coastal carbon dynamic studies, coastal pollution monitoring, etc. So coming to circuit ocean color, the basic definition is that the monitoring of oceans in the visible range of the electromagnetic spectrum is called ocean color. So where you can see, that means the remote sensing of oceans, which we are doing in the visible range, that is 400 to 700 nanometers, is considered as ocean color. And the primary goal is that we extract the concentrations of marine phytoplankton. Why we need to have phytoplankton is more important is that, which plays a major role in fixation of the carbon dioxide with the organic material, plays a major role in productivity. Apart from that, it is also responsible for the carbon sequestration are responsible for half of the Earth's net primary productivity. And it also forms the base of the marine food web and supports various industries and primarily for fisheries. The secondary goals could be separating the phytoplankton species like different coccolithophore blooms and harmful algae and all for marine coastal environmental and ecosystem studies. So mainly, if you see the bands, if you can see from here in OCM2, we are having 4.1. These are the central wavelengths which I'm telling about. Here the bandwidths are ranging from 20 to 40 nanometers, depending on the spectral region. First 6 bands, we are having the bandwidth of 40 nanometers. From 7th and 8th band onwards, we are having 60 nanometers bandwidth. If you can see here, the first band is having 412, 443 nanometers, 490, 510, and 555, and 670. So these are the bands which are useful for the various parameter retrieval. If you see these combinations of this, how the oceans looks, where we can see the clouds and other aerosol particles here. So we will see this. So the primary optical variable is what we are measuring from these things. Here, these are the bands which are used for the retrieval of parameters or constituents present in the water column. Whereas here, these are the 2 bands which are using for the atmospheric correction. So here, the basic parameter of the optical variable, what we are measuring is the water leaving radiance. That means the radiance which is coming from the ocean after interacting with the constituents inside this. And the primary biooptical variable, what we are measuring in the chlorophyll concentration in units of milligram per meter cube. So I'm giving a brief overview of the applications what we are doing here. If you can see this, basically these are for marine resource management, ocean productivity, synergic use of these surface winds and ocean color along with SST and SST will be giving for PFZ and other coastal cyclonic studies. Species specific forecast can be given fluvial fluxes, and then detection of phytoplankton bloom and HAPS monitoring. And it is also goes as one of the basic input, or it can be used for studying the biogeochemical cycles of the oceans. This also can be used for studying the dust storms, what you are seeing here on the right side of the image. So this is the fog and this is the dust territory which are over the Indo-Gangetic plains. This is the Sahara dust which is coming into the Gujarat coast and it is flowing like this. So this is also used as one of the, this also can be used, this other ocean color data can be used for the climate change studies, aerosols. So here if we call basic concepts of ocean optics, you can see this. Here this is called generally the remote sensing is of two types. One is the active remote sensing and the passive remote sensing. So here we are using our sun as a source, so it becomes a passive remote sensing. That means you are not eliminating any eliminating the subject or the object, whatever you are detecting with any active resource. So sun becomes the source of this, which becomes when it interacts the oceans, it either scatters, emits and transmits the ocean column. So whatever energy that is transmitted in the ocean column will be interacting with the particles which are present in the water column, like suspended sediments or other constituents, or the organic and inorganic materials. And then after interacting with all these things, the energy which is leaving from the water surface will be reaching to the oceans. So hence, if you see this block diagram, we can make it out. The total radiance, what you are measuring at the sensor level is a function of these all constituents which are coming through this. So which involves the simple light which is scattering from the atmosphere molecules and interacting and reaching the surface. And it is when it is interacting with the aerosols and the other particles and reaching the surface. Another one is the one which goes inside and getting these constituents interaction like this and reaching to the surface. One is the specular reflection, which is going, which is touching the ocean surface and simply reflecting that, means that doesn't have any sort of information about the constituents which are present in the water column. So total signal, if you see this, whatever you're measuring in the top of the atmosphere, LT, is a combination or cumulative effect of all these parameters. So what we are interested in is this LW. That means the water leaving radiance, which has gone transmitted to the ocean, interacted with us and taking the information along with it in the radiance form and reaching the sensor. So to retrieve this single parameters LW, you have to remove all these things. The radiance which is having in the path radiance, it is called, and then the radiance which is interacting with the atmosphere, something scattered, everything. So if you see this, the total signal which you are emitting will be 100%. That means if you remove this portion, only 5 to 10% of your total signal is coming from only from the water. So for this, what we have to do, we have to remove these all atmospheric effects and get this LW. So now it shows, it is understood that if you can make out, if you can see this, how stringent, how important it is to do the atmospheric correction to retrieve a single parameter which is having a very small information about 5 to 10%. So the thing what I'm saying, the same thing here written in words, saying that, so the main contribute, the OCRS or the ocean color remote sensing is the signal received at the satellite products considerably affected by the radiance contributions, which includes scattering of photons by the atmosphere, light reaching the sensor after specular reflection, sun glint, that means the specular reflection which is not at all interacting with the constituents and simply reflecting back from the surface, and the upwelling radiance which is coming from here. This is LW. So whatever is coming in the IFOV or the instantaneous field view of this this sensor will be having all this information. So generally for measuring this or to retrieve these parameters, we need to have the properties which are supposed to measure. There are two types of properties which are supposed to consider is inherent optical properties and apparent optical properties. So if you see this, the inherent optical properties are the properties which doesn't change as a function of either sensors weaving geometry or sources geometry. So that means the property of the object, like if you say that these are called like absorption and scattering, if you can say that, whether you measure during night time or morning time or any elevation angles, that property will not change. If you are coming to the apparent optical property, which depend on the geometry of the lighting distributed and the importance of the penetration of radiant energy that depends in the ocean waters. That means if you are measuring for example, if you take radiance, water level radiance, if you can see this, it will be having one sort of value when you're measuring in the morning time, and if you are measuring the same location, same with the same instrument at the noon location, it will be having one value, and you are going in the evening and measuring, the value changes. That means it totally depends on the distribution of the light field or the sensor geometry, and sometimes the source geometry also. So based on these properties, we can say that basically the ocean waters can be divided into two types, depending on the constraints which are present in that. One is the case 1 waters and case 2 waters. If you can see this in case 1 waters, where only one variable is changing, that is only chlorophyll. If you are, that means only single variable, the other variables are having not much influence, or they are sometimes absent also. If you are coming to case 2 waters, these case 2 waters are mainly influenced by the other constituents along with chlorophyll, like sedum, suspended sediments, and their other detritus particles also. Because of these presence of other constituents, these are also called complex, optically complex waters. But whereas case 1 waters are little simpler waters compared to case 2. Where we can find case 1 and case 2 waters? So case 1 waters are open ocean waters, where only the chlorophyll is the variable. If you are coming from the open oceans to the offshore, to the shore coastal regions, they are highly complex, because where the riverine inputs are there, using upwelling and other processes, the sediments are also getting involved, and then the traces will be there, inorganic, organic components will be there, which makes coastal waters very complex. These are called case 2 waters. Okay. So when you are doing atmospheric correction and then retrieving the parameters, you need to consider only the main product or the parameter which you are really interested in. If you see the BCG image of that, what you are seeing here, this is how it looks: oceans, and these are the clouds, and this is the land which is showing here. This is the RGB image. If we can see here that you can see here that this one is called specular reflection, which I was mentioning earlier. That means the light which is simply reflecting back from the ocean surface without having any interaction. After processing that, you can see this is getting masked, and it can be removed because we are interested only in this portion. So however, for any processing information, we need to have different flags and masks, because land portion you are not interested, you can mask it, and only the ocean portion can be retrieved. Like that, even in coastal waters also, you can flag some of them, like sandgline, coastal turbid waters, other things, and you can retrieve only the ocean information. What you can see here, the chlorophyll maps or chlorophyll distribution on the surface of the oceans. So the geophysical products that what you retrieve from the ocean at OCM is that generally there are 4 levels of products are available. One is the level 0 product. Level 0 product is not given to any user, where this is the sensor information which will be given to the sensor and the design people, where they will be having the raw data counts, and then that will be given, then that will be used for the next level, for level 1 products, where the basic data products will be there. One is L1A, L1B, L1C. L1A raw products are internal use only for BQ purpose. And when L1B will be used, the radiance product where it is calibrated. And L1C is the radiometrically corrected and geometrically corrected data will be used. So where you can see different combinations of bands, what I have shown you earlier in the RGB image. Then this L1B radiance product will be used for generating or used to derive the other geophysical parameters from the ocean color, like chlorophyll, suspended sediment concentration, diffusion attenuation coefficient, aerosol depth, aerosol optical depth. So after that, from level 2 to level 3, we can use, these are called the bin product. So these binning is all both spatial and temporal will be there. So in spatial binning, we can be having, because the native resolution of 360 meters cannot be used directly for all the process and purpose. If you want to study any mesoscale activities, mesoscale processes, you need not use only that much high resolution data. So that can be binned into 1 kilometer, 4 kilometers, or 9 kilometers, depending on your purpose and the application that you are considering. Then the spatial binning can be if a process or any phenomena, it is not daily or hourly. If it is of a very larger time scales, then you can go for weekly, then monthly and yearly products. If you want to study climate change and another seasonal activity and all, you can go for monthly. If you want to see the bloom dynamics or any little further finer features, finer dynamics, you can use the weekly products. So depending on your application and purpose, you can use both weekly, monthly and yearly data products. So these are the accuracies that are considered for ocean color radiometry. So any difference in 1% of water level variance will be leading to errors in 5% of your errors. So the stringent atmospheric correction needs to be carried out for retrieval of these constituents. So this is again the importance of phytoplanktons on I have written. So which plays a major role, marine ecosystems and all. So this is the one which you can say this chlorophyll absorption spectra, which is the basis for the retrieval of concentrations from satellite remote sensing. So if you can see this, the chlorophyll absorption, because in any plant or any green this thing, you are having different types of primary pigments and secondary pigments. If we can see this chlorophyll A and chlorophyll E, these are the major and dominant pigments which can be absorbed from the space. Hence, the retrieval of chlorophyll A is only considered because 80% to 90% of the chloroplast or the phytoplankton cell is covered with the green pigments. Hence, it is required or it is adopted to retrieve this chlorophyll A concentration rather than other pigments, because the content wise and the presence of these things will not give any significant retrievals or the significant observations from the space-based platforms. So there are various algorithms which are available for a period of time from Caesar CS onwards, based on the number of bands which are there and number of the concentrations which are ranging from 0.1 to almost 50 to 60 milligram per meter cube. So if you can see this algorithms where Ocm1 has been used, or OC2 and OC4 algorithms, where OC2 will be used, will be using two spectral bands, that is from 490 and 555 spectral band. And then if you are going for OC4, you'll be using four spectral bands varying from 412, 440 to 490, 510 and 555. Where if you can see the previously the spectra where 555 plays a major role in almost as sort of no variability will be observed, not in any one of the pigments. So it forms the base of the algorithm or for normalization. So based on these basic spectral behavior of various pigments, these algorithms have been developed. So if we can see this, the retrieval of these bands or the retrieval of these constituents depends. Why here is that it's not that only one band is sufficient. If you see this here, the maximum concentrations which you are observing or the maximum values can be taken from 440 through and 490. And we are coming to the other regions, you can see the contributions are very less. That means 0.1 to 1 milligram per meter cube, the low concentrations, the mid concentration, the high concentrations. Depending on the concentration levels, we can use these algorithms or these bands. But when you are processing or using any global product or any data which covers both open ocean and coastal oceans, we cannot take one single band and use. Hence, we are taking the maximum band ratios where the entire variability of concentration is considered, and it picks the maximum variability in that and takes that as a contributor for using your algorithm for retrieval. So that's why different band combinations are used here. So here also we can see this different types of sensors which are having the key wavelengths and the major wavelengths which are used for estimating the concentrations from Caesar CS to till date, and the different satellite sensors which are launched by this, and the algorithms which are still present for processing their products. And from here you can see different products, how it looks, the global products. So based on that, the ocean waters are divided into three types. One is the oligotrophic waters, isotrophic waters, and eutrophic waters. The sense that the oligotrophic waters are representing the pure oceans where there is no variability, except chlorophyll are almost, you can say, the plain waters. Even the chlorophyll variability is from 0.1 to 0.5. So beyond that, you cannot observe. These are also called ocean deserts, where much of the phytoplankton, absence of phytoplankton is there. If you see these regions where you are called mesotrophic waters, where the concentrations are having from 0.5 to or 1 to 3 milligram per 5 milligram per meter cube, whereas the other eutrophic waters means in the sense that they are nothing but case 2 waters where the variability or the concentrations of chlorophyll is high. Apart from that, chlorophyll, there are other constituents which are present. Eutrophication means it is sort of highly complex waters where your light penetration will be very minimal compared to the open oceans. So coming to the Ocean-SAT-2 sensor, which is there here, launched by ISRO, where this is the Ocm1 sensor, and then 2, these are the specifications. Both of them are having 8 bands. However, in Ocean-SAT-2, the spectral band of band 6, which was there earlier at 640 nanometers, a central wavelength, has been shifted to 620 for the better quantification of suspended sediments. Apart from other than these two, all other specifications are same. However, Ocm1 is having an in-house developed software, the package for processing this. Now it is enabled for processing through CDAS with the global sensors and other atmospheric correction processes can be implemented or can be adopted here. However, this one is only for LAC or the global local coverage only. But now, as I showed you earlier also, this is for the global coverage, global waters also. So this is how the Ocean-SAT-2 looks, or the coverage looks. This is the local area coverage, which covers the Indian waters, covering both Arabian Sea and Bay of Bengal from 0 to 30 degree north, and from 40 to almost 120 degrees east. So if we coming to the GAC, or the global area coverage product, which is having this descending order acquisitions, where it will be covering the entire oceans, so entire global oceans or entire globe in 8 days. So this is how the chlorophyll product, which looks looks over the NAO, North Indian Ocean, after processing it. So here you can see various seasons and the dates for the chlorophyll concentration of NIO. This is the GAC product of chlorophyll A. So here you can see these applications. Some of them I am showing you this. The phytoplankton blooms which are observing for the time period of from 1 to 13. You can see how it is every year, how they are coming, how they are spreading, how the bloom is forming. The peak stage and diminishing stage also can be studied here. The coastal fronts also can be studied. So these are the basic applications which you can study from the ocean color. So this is another case study where you can see the phytoplankton bloom is observed in the coastal waters of Kakinada during March 2012 has been studied. So the initial phase and the peaking phase and diminishing phase of the bloom has been studied, and this has been validated with the instrument measurements what you are observing the plus ones, and has been already identified the bloom species as a diatom. So this is the result of it. The time series analysis of a particular area, the same study area has been carried out using OCM2, where you can see how over a period of time, the seasonal ERL, this is actually the 2-day composite which has been used for studying the chlorophyll variability in that region. So this is how the seasonal variability from 2002 to 2004, the climatology has been studied. So the variability shows that the blooming of this region occurs or initiates the mid of March and peaks in the month of April, and by May it is getting diminishes. So this is how the bloom dynamics can be studied using Ocean-SAT-2. And this is the time series analysis of chlorophyll from OCM2. So you can see this during non-bloom period how it looks. January, February, March, April, and these weeks, how are the blooms are extending, are the filaments which are going into Central Bay of Bengal, and how they are evolving. This is for 2013. So you can see the features here in the month of May, how it is coming. If you see the previous one, you can see this. This again depends on the currents which are there in the ocean, how it is moving. The movement of the bloom patches can also be identified. So if we superimpose currents on that, so we can see the movement of patch, and the persistence of patch also can be observed. So this is how this analysis can be carried out over a period of time. This is for 14. So this is how see the intensity of bloom during the month of April also can be seen here. If you see this can appreciate that how the bloom is varying over a period of time. As I was telling you earlier, the synergic studies, if we can say this, this is the case study which has been taken for the Titli cyclone, how the chlorophyll that induced are the increased primary productivity after the over cyclone passed in the Bay of Bengal. If you can see this, these are the cyclonic eddies, warm core and cold core eddies, where the cyclone is passed over that, and then this data can be used for how the cyclone means cyclone is passing, the path can be predicted, and you can also use these things for the intensification of the cyclone. So for these kind of studies, you can use these eddies along with the chlorophyll information and the patchiness. So this is also another study which shows that the utilization of TCHP along with chlorophyll shows the evolution of this. If you see the chlorophyll, the PP here, so which is forming on the right side of the track where you are the intensity which is persisting over a period of time in that region. If you can see this and this patch, you can make out how the chlorophyll patch has been evolved. So the concentration and the number of the concentration increases depending on the persistence of the wind patch and the eddy that is present over there. So if you are the winds are having more and more over a particular region for a longer time, the intensity also increases, where that causes the deepening of the mixed layer, and where it has churns from the deeper layers to the surface. So in presence of that, you can see after a lag of 5 to 88 days or 10 days, you can find the high blooming in the surface waters, which is representing in this image. This is another case study which has been carried out using a generation of the PCO2, or the partial carbon dioxide, partial pressure of carbon dioxide, for estimating the ocean biogeochemistry, where the chlorophyll goes as one of the inputs here. So here we have taken the Moody's chlorophyll SST and salinity data and produced these, which has already been published in this journal of downstairs. There is a reference is there. There we have already published this information. So apart from this in situ measurements and the ocean color information has been taken for generating the PCO2 maps over the Northern Arabian Sea, North Indian Ocean. So this is the data which has been produced. You can see the source and sinks of carbon dioxide from this. So we have used Ocm2 chlorophyll, the SST from Nova AVHRR, and salinity from the Aquarius. So this is how we can study the seasonality of the carbon and the intensity of the PCO2, how it is varying over a period of time, both weekly and seasonal. So we have also seen this the water clarity parameters, how ocean it is transparent, or what are the pollutants which are affecting into the coastal oceans, or you can use the pollutant studies. So here we have taken the Tamil Nadu coast covering from the northern to the southern Adayar region. So from the during pre and post lockdown periods, how it has been affected has been studied. So for that we have taken the climatological data from 2002 to 2020, and over a period of 20 years how it has been changed. And one is the short-term study, which is before and after, whether any influence has been there, any change has been observed, any reduction in the water pollutants has been studied and has published in this. And again, apart from the data, whatever we are collecting is getting validated. Here you can see the data which you are measuring the case 2 waters, and this is the case 1 water spectra. So if you can see here that the data, whatever has been measured in the coastal regions, we can see this here. This is Transex. So the algorithms which are available like OC2, OC4, OC3, and other algorithms also works well, or performs better in the in this study area what has been carried out. So this is the result which is present in also published. You can verify that. And apart from that, this is the bloom validation which has been carried out for the 2012 cruise, and this has also been validated with the existing algorithms has been identified, and then also proven with the HPLC data for the pigments characterization has been done. So the bloom which is identified is the Nactiluca bloom. So this is the one which, so based on the previous experience in the other information, we can say this. Earlier in OCM2, we are having only the blue bands, which are having eight bands, which are represented in blue. Now in OCM3, we have proposed almost 13 bands where you can use these things for various applications like specific pigment detections, bloom detections, and for absorbing aerosols apart from these normal applications. And then also another band has been introduced in 1040 nanometers for atmospheric correction. So this is the improvements has been done for OCM3. So generally what we have seen is that what are the challenges which we have is that accurate remote sensing of the water properties is still challenging for the coastal complex waters and inland water bodies. So because of that, and when you are doing atmospheric correction, the strong absorbing aerosols are the main culprits. They are the one which needs to be addressed again. So apart from that, the retrievals will be a little simpler in the open ocean regions. So these are the things which we are now doing. And the next steps is to continue to effort for improving the remote sensing data products for coastal and inland waters. The way the transition path is lying is that where we have been working on transition of research to operational speed band based algorithms for retrieval of atmospheric correction, and then processing that for the parameter retrieval. So in conclusion, we can say that it is designed to study the marine ecosystem, recognize essential climate variable, and these are also used for serving various purposes like ecosystem studies, dynamics, plankton phenology, chlorophyll concentrations, and then along with the other parameters like SST and sea level aerosols. So it will be used for various these will be used for synergetic applications for coastal fisheries, etc. Thank you. So apart from that, I will show you some of the applications you can see here, AOD and retrievals. These are the PFZ lines which you are giving from OCM1. These are all applications. Previously, I have shown from OCM2. Now these are the PFZ lines which has been given for OCM1. Cyclone studies, sediment transportations and vectors, how they are moving. So this is the sediment plumes which are coming into this. Sediment eddies, how the sediment is getting transported into the Bay of Bengal from the Devi River. So these are the coastal filaments which you are observing here, the plumes which are extending into the open oceans. Salinity fronts can be studied. And then this is the one which is there for coastal oceans upwelling regions. That's what I was telling you to Katina region, how these blooms are getting formed. So these are the fronts which are observing how these are getting into disseminated or deposited in the central oceans. So this is the coastal bathymetry which has been retrieved. This is again suspended sediment concentration, how these are affecting. So this is the naval exercise which has been carried out in Arabian Sea, has been captured by OCM very nicely. These are the ships which you can see, ship trails you can see here. These are the bloom patterns. This is another image where you can see the small ones, small ships and all. So these are the bloom patterns. These are the bee blooms in the month of February, where we are having central northern Arabian Sea is dominated with the phytoplankton blooms. You can see the ship tracks, and from there you can find the velocity of the ships also. So these are the eddies, chlorophyll eddies. These are the one which are dust aerosols which are coming over the Indo-Gangetic plains and getting deposited into the central Bay of Bengal. So another application is that these dust aerosols which are having high rich content of iron will be having an impact in enriching the phytoplankton growth in the oceans. The study I have not shown, but this is one of the applications which you can see. Thank you. Thanks for your patience listening.
Thank you, ma'am.
There's a chat book, something is there.
I unmuted so that you can ask many questions to ma'am. If any questions, you can ask.
Hello.
Hello,
Am I
ma'am.
audible? Yeah. I'm
Yes,
Vijay
ma'am. Yes,
Singh.
you can.
I just wanted to, you just showed last few slides on the pre and post COVID time. What is the kind of changes? Can you just throw a little bit light on the observations on the past 20 years and the immediate changes pre and post COVID, madam?
Yes, madam. Actually, if we see the presentation, so generally, whenever we see any deviations from very shorter periods, better to go for the climatological data products, because over a period of time, if you see, generally this is the suspended sediment concentration which has been observed, and if you see here in this, you can see the water transparency. If there are any effluents, are there any pollutants which are coming and joining into the river, can be seen just before and after. But if you want to see the real changes, then we have to see the climatological data parameters that has been taken for a period of 20 years. That paper is available. You can just simply go through that. This is the parameter which we are using, water transparency, KD 490, where the light penetration is more in the open oceans, where if you are coming to the coast, it is less. So transparency gives the clarity of the water column or the water quality, whether it is clear waters or water which are having the other influences, other pollutants.
That is about the pollutants, and one more thing is the marine plantations, no, whatever the algae, the improvement on that one was observed, or how was this? Is about the water penetration, so light penetration into the water, which shows the quality of the water in terms of its clarity, right?
Yes,
And
ma'am.
then that is with respect to the pollutants. And anything with respect to the marine.
But actually, this paper is exclusively for showing the differences or the water quality before and after COVID, during COVID, because generally it was a total industrial lockdown was there, where we can see there's less effluents are into the ocean, where your water transparency has increased. However, this climatological studies, what we have seen for the Kakinada coast, where the chlorophyll concentration changes over a period of time, has been studied from Ocm1 onward, that is from 1999 to till date. Once particular area, that means over a period of 15 years has already been studied, madam. That is not in this paper. But that increase or decrease, we can see only that not for Tamil Nadu coast, but Kakinada we have studied. The increase, that if you can see the previous 1 minute. Kakinada coast. This is how the concentration. So if this data is also available under NICE's NICE's ECSA portal, madam, in Bhuvan from ISRO website. You can download the data or take a small region, not the entire region, and you can see the variability over a period of time, how it is varying. Either you can take 2-day product or 8-day product and can see whether the chlorophyll is increasing, which year it is increasing, how far it is, having, means we had to segregate the data into your restricted grid, and then you can see the variability. This is how the total weeks it shows for a period
Okay,
of
madam.
time.
Yeah.
This this study has not been carried for Chennai coast, but it was done for Kakinada coast.
Okay. Thank you, ma'am.
Thank you.
Incidentally, this OCM1 was my first launch support.
Oh, now the data, madam, we are reprocessing it because of some intricacies. So for a particular region, if you want, you can study. And the facility is going to come up soon, where you can analyze for very small regions only, for not the entire Bay of Bengal or NIO, but you can do the time series analysis. Not only with the OCM, if you can go for OCC site also, you can find these variabilities are the increase or decrease of this chlorophyll at a specific location of your interest.
Thank you, ma'am. Actually, the presentation was very, very informative. Thank you.
Thank you, madam.
Any more questions? Okay. Nagmani ma'am, shall we end it?
Yes, madam. No problem.
We have very thankful for your accepting our invitation, ma'am. It's a very informative session for us. It's a pleasure to have you in Creative, ma'am.
Thank you, ma'am. Thanks for the invitation. I am not sure that everybody got some information about it, but if anybody wants to discuss regarding these ocean color activities and the remote sensing applications of this and further utility, they can contact madam, no problem.
Yes, ma'am. I will connect you.
Okay, ma'am.